record. All right, so in organic chemistry, there is a concept that we use, functional groups. And here you can see the definition for it. A functional group could be an atom, just a single atom, or a group of atoms within a molecule that is responsible for its characteristic chemical reactions. Most of the time, they contain oxygen, nitrogen, sulfur, or phosphorus. Okay? They are also called functional group. I don't want to stop here. As we discussed before, the alkanes, this homologous series, this type of compounds are very unreactive. If you will, you can call these compounds the noble gases of the organic compounds, because they don't react easily. Only like 2 or 3 types of reactions can be done on the alkanes. And just as a review, I'm going to mention that you can either burn them, so they undergo combustion. This is when you force the carbon atoms that you have in the alkane and the hydrogen atoms that you have there, you force them to combine with oxygen. And out of this combustion reaction, what do you get? What do you get when you combine carbon and oxygen?
Carbon dioxide.
Carbon dioxide. And what do you get when you combine hydrogen and oxygen? Water. Water. Actually, the chemical name for water is not water. This is a common name. It's hydrogen.
H2O?
I'm sorry?
H2O?
H2O, yes. The chemical name is hydrogen protoxide. Protoxide. Okay. Now, combustion is one of the reactions that you can find in the alkanes. Also, halogenation, that means adding halogens to it. And decomposition, this is cracking, breaking down a large alkane and breaking it down into smaller alkanes. These guys here, the alkenes, now they have a double bond, as you know. They consider this double bond to be a functional group because this is no longer alkane but a different substance, alkenes. And the 2 bonds that you have here, I'm going to draw something on the screen so that you can understand me better. They have 2 bonds in between any 2 carbons. When you have that, you have an alkene. Now, these 2 bonds that you have here, one of them is very, let me see if I can get this. So I need to show you something, but I'm not, okay, here, I found it. One of the double bonds is very strong, very, very thick. The other one is very thin, okay? Every time you have a double bond, you have one that is very strong, very stable. They call this the sigma bond. This is the sigma bond, the strongest one. And this one, which is very weak, very thin, is the pi bond. Okay, this bond can be broken easily, can break it easily. That's why whenever you have an alkane and you have an alkene, if you have, for example, a propane and you have a propene, the propene will always be more reactive than the propane because it has a double bond and the second one is very weak. When you have an alkyne, which is triple bonds, you have 1 strong bond and 2 weak bonds, okay? Actually, the third one is even weaker. So these compounds are more unstable than the alkenes because the alkanes only have strong bonds. and they cannot be broken down easily. Now these guys can break these bonds easily. And then if you have, for example, I'm going to make this propane. Let me delete the last bond that I put here, this one, just to have a propene and not propyne. And then, and this is now talking about the chemical reactions that these substances undergo. If you now add hydrogen to it, let me put a thicker pencil here. If you have a hydrogen molecule, you can add it to this compound, and then guess what is going to happen? H2 is a hydrogen molecule. Oh boy, I don't know why my mouse is misbehaving like that. H2, that's the same thing as saying, this is the same thing as saying H dash H. So 2 hydrogen atoms I have there, okay, H2. So these 2 hydrogen atoms now will separate. Of course, this takes place in the presence of a catalyst. And now this double bond is broken down, it splits in half, and here one of the hydrogens is attached, and here a next hydrogen is attached. Okay, then the double bond disappears. I'm going to erase it from here so that, oh no, that's not what I meant. Okay, much better. Okay, that's what we get at the end. If you add a hydrogen molecule, the double bond is going to break, and then 2 hydrogens I'm going to attach to the 2 carbons that were sharing the double bond. This type of process, this type of reaction is called hydrogenation. This is adding hydrogen to an alkene. And yes, that could happen in an alkane too. Is that clear? Do you understand what happens here?
No.
Were you paying attention when I said it?
Yeah, you lost me after you were explaining the breaking of the bond.
Okay, you have a double bond here. Remember, the double bond has a very thin bond, which is the pi bond. This one very weak, can be broken down easily. So when this is in the presence of hydrogen, and you have a catalyst that I'm going to tell you in a minute, the 2 hydrogens that you have will separate, and each hydrogen is going to attach to one of these carbons that were sharing the double bond, because this double bond now breaks apart, and this part of the double bond will be available here for one of the hydrogens, and this part is going also to be available for this hydrogen to attach. That's what happens. And this type of reaction is called hydrogenation, which is the addition of hydrogen atoms to any molecule. Okay?
Okay.
All right. So not only hydrogen can be added to an alkene, also, and I'm gonna go back to the very original thing that we had. Not only hydrogen, but also if you have water, H2O, if you have water, this will also break down the double bond that you have here. Remember that water is 2 hydrogens and 1 oxygen. So you have hydrogen, bond, oxygen, bond, hydrogen. So when these 2 substances mix, it could be any alkene, okay? Any organic molecule with a double bond. Now the water molecule breaks down, okay? And in one of the carbons, you are going to have the OH. And in the next carbon, you are going to have the H. Because this double bond breaks apart again. And then this part of the double bond is where the hydrogen attached to this carbon. And this available bond is where the OH now attached to this carbon. And this forms a next substance. Oh, by the way, if you add hydrogen to an alkene, it was unsaturated at first because it didn't have all the hydrogens that it could hold. Now, because you add hydrogen, it's going to be saturated because now it's going to have all the hydrogens that it could hold, that it can hold. In that case, you convert an alkene into an alkane because you broke down the double bond to add hydrogen. Okay, now in this case, this is not an alkane because you have something that is new. And this that you see here is also a functional group. This makes this a whole different substance. This is not going to be just propane, as you might think. This is a new substance that I'm going to teach you in a couple minutes. Remember, as I said before, some functional groups contain elements other than carbon and hydrogen. They might contain oxygen, like in this case. Oxygen is the only new element here because you already had carbons and hydrogens. Now the oxygen attached to a hydrogen gives to this molecule a whole different identity. This is no longer propane. This is going to be something new that I will share with you now. Before I move on, is there any questions on this matter?
Not yet.
Not from Royan? Anybody else? Anyone has any questions? If not, then I'm gonna move on. But still, if questions arise, just let me know and I'll be more than glad to assist you. Remember, in the alkanes, you have only carbon and hydrogen, and all of them are single bonds. That's why the name ends in "ane." Now, in the alkenes, you have double bond. Remember, one of these two bonds is very strong, the other one is very weak and can be easily broken, right? If you have three bonds, if you have a triple bond, then you have an alkyne. Only one of the bonds is strong, the other two bonds are very weak and can be easily broken. Okay, now this is the one that I wanted to mention to you. One of the functional groups is OH. OH. This. They are supposed to move together. OH. It has a name. Hydroxyl is the name of that functional group. Hydroxyl. Hydroxyl. That's the name of this functional group. Right? So whenever you have a hydroxyl, OH is not just the O by itself or the H by itself. It has to be both of them together. This gives you now a different substance that is an alcohol. All you have to add is one oxygen and put it in between the carbon and the hydrogen that was there. So you have the OH group. The alcohols can be primary, secondary, or tertiary. And this depends on the type of carbon where the OH is located. For example, remember that we discussed that you have primary carbons. Anybody remembers what is a primary carbon? A primary carbon is a carbon within a chain that is attached to only one carbon atom. For example, this carbon that you have here is primary because it's attached to only one carbon atom. Now, in some cases, you will have carbons that are attached to two other carbons. For example, this one here is attached to this one, and you can also have a next carbon here if the chain continues. In that case, this would be a secondary carbon because it's attached to this and to the one that you might have here is if the chain continues. And we also learned when you have a tertiary carbon. Tertiary carbon. When is that? What do you need in order to have a tertiary carbon?
A triple bond.
Sorry?
A triple bond?
Oh, no, not a triple bond. Because even if I have a triple bond here, this wouldn't make this carbon a tertiary carbon. This is still primary because it's attached to only one carbon. It's not the amount of bonds that it has, but how many carbons are attached to it, are bound to it, okay? So what do I need if I want to have a tertiary carbon?
2 more carbons connected.
2 more carbons?
Side.
Let me see if I understand what you're telling me. Right there I have CH3, that's the first carbon, and then I also have CH2OH. That's how you write this. If I put 2 more carbons, then that will be a tertiary carbon.
No.
Okay, how do I make one of these a tertiary carbon?
It would be CH3 and then C and then CH whatever.
Okay, I didn't get that. Can you repeat it?
CH3
Mm-hmm.
CH.
Just CH?
Yeah.
Uh-huh.
And then CHO2.
CHO2?
No, that's the right last one.
Okay, let me help you with that. Whenever you want to have a double bond, I mean a tertiary carbon, you need to have a branch. If you have a branch, then you will have a tertiary carbon, because then this carbon is going to be attached to 3 more carbon atoms. This one would be tertiary because it's connected to this carbon, is connected to this carbon, and is connected to this carbon. So it's tertiary. Is that clear?
Yes.
Okay, now alcohols can be primary, secondary, or tertiary if the OH, if the hydroxyl group is connected to a primary carbon, a secondary carbon, or tertiary carbon. Okay? Anyways, let's move on with the alcohols. Let me see if I look at this. This is what I meant. This is a primary alcohol because the OH is attached to a primary carbon. This is also a primary carbon, so this, even if you put it here, it's still primary alcohol because both of them are primary carbons. Again, why are they primary carbons? Because they are attached to only one more carbon. Now, this example here is a secondary alcohol because the OH is linked to a secondary carbon. What makes this carbon to be secondary? Oh, because it's in the second position. No, it's not. It's because it's attached to 2 more carbons, okay? Now, this guy here is a tertiary carbon. Therefore, this is a tertiary alcohol because the OH is attached to it. What makes this a tertiary carbon? The fact that it's connected to 3 carbons. The one in front of it, the one behind it, and the one below it. Okay? Okay?
Yes.
Okay, I don't want to go into the different functional groups. I want us to discuss the alcohols for now. But I'm going to stop sharing for a minute and I'm going to show you something. I'm going to share something with you. It's a list of functional groups and I will need you to screenshot it, not write it because it's going to take too long. So screenshot it or take a picture of it. Whatever you do is fine, but I need you to keep this. I need you to have this. This is very important. We will use it for a long period of time. So I'm gonna pull up this picture here and wait for you to take a picture of it. This one here, these are the functional groups. Okay, this one, disregard the R that you might have next to it, because the R just means radical. This is just a chain. So whenever you have any chain attached to this functional group, this is the functional group, then you are going to have an alcohol. Okay, hydroxyl is this functional group. Carbonyl is when you have an oxygen atom attached to a carbon by a double bond, through a double bond. Notice that here you have oxygen and hydrogen, and this oxygen is attached to the carbon part of this chain by a single bond. But when the two bonds that oxygen has are attached to one carbon, this is a carbonyl, and it gives two different type of substances, ketones and aldehydes. I'm gonna show you a next picture. Let me actually get you that picture that has the actual names of the compounds that you get with this. Okay, this one doesn't give you the name itself, but still, I think I can share it with you. Okay, this is a little bit more inclusive, if you will. We have the alkanes here, which is just a chain with carbons, and that's it. You have the examples here and how did you name them. The alkenes is the ones with the double bond, the alkynes with the triple bond. The dienes is when you have two double bonds. Now, alcohols are the ones that contain the OH, and the names for them will just end in ol, okay? With oxygen, you might also have the ethers. Ethers are those that have a chain, an oxygen, and another chain. So you have like an oxygen in between two chains, between two radicals. That's how they call the chains, radicals, okay? And these are the ethers. Now, using the same element, oxygen again, you can have the aldehydes. If you have the oxygen attached to a carbon atom by a double bond, through a double bond. And if it's located in a primary carbon, is an aldehyde. Now, if the same oxygen attached by a double bond to a carbon is located in a secondary carbon, this is secondary because it's attached to two carbons, remember. One in this chain, it doesn't matter how long this chain is to this side, and it's attached also to this carbon, part of this chain. R means a chain that could be any length. Now, also using oxygen, you might find these are called ketones, and the name for them is ending on. Today, we're going to discuss the alcohols. This is what we're going to discuss today. But I'm mentioning this one so that whenever we get into this, you have an idea on what we're talking about. Take a picture of this again, because we're going to use it. Okay? Ketones. Now, carboxylic acids, this is when you have the very oxygen attached to a carbon. And then also you have the hydroxyl, the functional group for the alcohols, and the functional group for the aldehydes and ketones, okay? When the combination of these two produces a carboxylic acid, okay? Now, esters now, these guys is when you have the oxygen attached to a carbon through a double bond. This carbon is attached to a chain. It doesn't matter how long it is. Also, you have a next oxygen and another chain. These are the esters. Okay. Amides is the same thing, but instead of an oxygen, you have a nitrogen atom that is attached to a chain. Amines is a chain attached to a nitrogen atom. Nitriles, this is when you have a chain attached to a nitrogen through a triple bond. And thiols are these. But this could be very confusing if we don't go into one by one in details. So I'm gonna pull up the information about the alcohols to explain how they are formed. I just gave you one example of them. If you add water to an alkene, you get an alcohol. This is how you can obtain them. But I want to go into the nomenclature, how to name them, where to find them, what is the use that we make of them, etc. So I'm gonna stop sharing. I'm gonna pause the sharing and the recording for a minute until I pull up the file with the alcohols information. Clean up, use it in the medical field, they use it as a drink, they use it as a fuel, and all of this is alcohols. Now remember, alcohols are organic compounds made up of carbon chains that contain this functional group, hydroxyl, which is the OH. R is any chain, could be a methane attached to OH or an ethane attached to OH or propane. It doesn't matter how many carbons it has. R is the representation of any chain. That chain attached to the OH forms an alcohol. Notice OH by itself is not alcohol. You need to have both things. Now, using the same functional group, if this is attached to a benzene, this guy is not alcohol, but phenol. Okay, that's the name of the compound made up of the benzene and the OH, phenol, the aromatic compound, right? So let's move on. How to name this, the alcohols? This is the same procedure that you follow when you're naming alkanes or alkenes. You will find the longest chain of carbon, but you need to make sure that that chain contains the hydroxyl group, the functional group, the OH. Then you will number the carbon atoms in the chain so that the carbon that is attached or bond to the OH group has the lowest possible number. So this will have priority in the chain. This is what will dictate where you will start counting your atoms. Now, form the parent alcohol name by replacing the letter E from the alkene. So if it's ethene, you will replace the last E by these two letters, ol. So it's going to be called ethanol. If it's propane, if it's propane, it's going to be propanol. If it's butane, it's going to be butanol. Okay. If isomers are possible, you will find where the OH is located by placing the number of the carbon. And that means if you might have the OH in many different carbons, then you have to say in which carbon is located. You have to say like 2-pentanol, for example, stating that the OH will be in the second carbon in the pentanol, in the pentane chain, right? And after that, or before that, you have to name the branches, the alkyl branches, methyl, ethyl, propyl, etc., or other groups if there are present. Okay, this is an example. We locate the longest chain that has the OH attached to one of its carbons. So even if this chain would be longer, let's say that we have 4 more carbons here, we wouldn't choose this as the parent chain, okay? Because we need to include the carbon that contains this. So you have to go like this. You have to include this carbon in the main chain. So this would be our chain and not this, not going down. This has to be included. So this would be our parent chain. We have our OH here. The second step, once is identified, you have now to number the carbons as you learn, making sure that the OH is in the lowest possible number. So if I start here, this would be carbon number 1, 2, 3, and 4. Now, if I start here, the OH will be in carbon number 2. Therefore, I decide to start counting here, and this will be carbon number 1, 2, 3, and 4. This one doesn't have any number because this is not part of the longest chain. This is just a branch, right? So the name for this, because it has 4 carbons, is going to be butane. We add the suffix ol, so it's butanol. But the butanol could be, the OH could be in carbon number 1 or in carbon number 2. Never would it be in carbon number 3. Why wouldn't be in carbon number 3? Why is not possible to have 3 butanol? Anyone knows?
You can't hold it.
Because
What you say, Romeo?
Yeah, because you can't hold it because it already has the 2 things attached to it.
No, remember, as long as you have hydrogens, you can just remove the hydrogens and attach something else. So yes, it fit here. That's 1 and 2. It could be another chain. I mean, in general, you will never have such a thing as 3 butanol. Why? Not only in this case, not only in this example, but in general, you will never have 3 butanol. Why? Because the moment you locate the OH here, then you have to start counting on this end. This will be carbon number 1 and carbon number 2. So this will always be in 1 or 2, no 3 or 4. You got it?
No, can you repeat that again?
I will repeat it again. If I place the OH, the hydroxyl, on this carbon, then that wouldn't be 3 butanol, because this wouldn't be carbon number 3. This now will become carbon number 2, because I have to start counting at this end. 1, 2, because here I would have the OH, and I have to make sure that the OH is always in the lowest possible number. The location of this OH determines where I will start counting. I started counting here because if I start here, OH is going to be very close to this end. Now, if I place it here, it's closer to this end. So I start counting at this end, and this will be carbon number 1 and carbon number 2 then. So it's never going to be carbon number 3 within a butanol. Okay? You get it now?
Yeah.
Okay. So this is 2-butanol, and I have to say that it's in the second carbon because it might be in carbon number 1 or carbon number 2. So because people are only going to see the name and not the formula, with this name, they have to know, they're supposed to know what you are talking about, where everything is located. In the third carbon, I have a methyl. In the second carbon, I have an OH, I have an hydroxyl in a 4-carbon chain. That makes it 3-methyl-2-butanol. Now, they, in the last days, lately, they're naming it this way: 3-methyl-butane-2-ol. They are including the number of the carbon in the middle of the name, right before the suffix ol. Okay, both of them are accepted still, but this is what they are pursuing for now. This is what they are using as the most modern name. Okay, look at this one. This is the parent chain. Where do we start counting here? This end or this end? Hola.
From the right.
From the right side, from the right to the left. What would be the name for this compound?
Sorry. 2-pentanol. Are you
Oh.
supposed to put the branch first? So then it would be 3-methylpentanol? Pentanol? Methylpentanol?
You're missing something. Only one thing you're missing. Can anybody help her?
Pentanol?
Yes, say it. Say the complete name now.
3-ethylpentanol?
Okay, you made a mistake again. Go ahead again.
3-ethanol 2-pentanol?
You say ethanol? No, we have no ethanol here.
That's no, no, it's no.
Say it again, Romeo.
Met.
Okay, yes. So what is the entire name? That's what I want to hear.
3-methanol 2-pentanol.
But why are you saying methanol? Is this a methanol?
So you just leave it as methane?
No, these have never been methane. What is this? What is a branch that has only one carbon? Huh?
Methyl.
Methyl. Come on, Ryan.
I'm sleepy. Anyway.
What's the name of the
No,
compound?
Somebody else can say it, you know. 3-methyl 2-pentanol.
Good, finally. And what is the most modern form for that name?
Huh?
What is the most modern name for this compound now? 3-methyl pentan 2-ol. Like this. You remember the number right before the suffix ol? Okay, the meeting is going to end in less than a minute. Please join me back one time so that we can continue. All right? I'll see you back.